Alright, this lesson is on chapter 6.6. This is the last actual lesson for the unit. After this, we'll review for 3 days and try to get some things down. My advice to you, if you have had any issues with elimination, substitution, or the word problems, is that you go back to your Google Classroom documents and find the videos that are on elimination, substitution, and the word problems, because those questions are still going to be on the test, and even though we'll do a brief review every one of these days, you want to make sure that you understand it. So it's up to you if you need that to go back and do it. Other than that, we're going to look at this problem here where we actually have two graphs to put into one system. So the problem just asking what the graph of the system is, and they give us two different graphs. This is where we have to remember our training in terms of what's going on. I recognize that this is a slope-intercept graph with y equals, again, I imagine this like an equal sign, but if it was y equals 2x minus 3, the first thing I would do is go 3 down. Again, I'm going to mark this to let the person know I'm counting by 1. I'm going to go 3 down, 1, 2, 3, put a dot, and then the 2 as my slope. Remember, again, I remember that 2 is equal to 2 over 1, which means I rise 2 and run 1, and then I use a straight edge to draw a line. Paying attention to this, because that is a less than symbol and there's no line under it, that means that this should be a dashed line, not a solid line. So I draw a dashed line all the way across this region. And from what we learned the other day, we will now test 0, 0. And when we go to test 0, 0, I want to write it out so I get credit. I get 0 less than, well, 2 times 0 is going to be 0 minus 3. Is 0 smaller than negative 3? No, 0 is actually bigger than every negative, which means that this is false. And here's the situation that we bump into. We will have two graphs, which means if I shade this whole side, it will actually get very confusing, especially when I go to do the second one. So here's what I'm going to do instead. I'm going to do what I call alligator teeth, which means that I'm just going to do a slight shade on this side. Because again, if it's false, I'm going to go this way, but again, it's just a slight shade on this side of the graph. That way I understand that this is the side that we would shade if we were to shade the whole thing. Again, it's kind of like a little wave, but the way I view this is as a set of teeth. Now what I'm going to do is go back and graph the second one. This is not slope-intercept form, which means that I will find the x-intercept and the y-intercept. The x-intercept here is from ignoring y, from what I remember, and I get 2x equals 2. Again, I treat this like an equal sign until I graph it, which means that x is 1, so there's a dot right there, because that is the x-axis. When I go for my y-intercept, ignoring x, I end up with y equals 2, which means that my y goes right here. And again, because this is a less than symbol, not a less than or equal to symbol, there's no line under it, I am going to draw a dashed line through this region. Again, I'm going to test 0, 0 because it's available. So 2 times 0 is going to be 0 plus 0 greater than 2. 0 is not greater than 2. That is also false. And so I want to go away. And so again, instead of shading the whole thing and confusing it, I'm just going to jump over this line and put a set of what I call teeth on this side of the line. In the end, I have now separated this into 4 regions. And the region that is my final answer is the region that has 2 sets of teeth. As I look at this one, there are no teeth here, which means this cannot be it. As I look at this region, there are teeth on this side, but there's no teeth on that side. Again, if this was a mouth, alligator's mouth, there are teeth here, no teeth there. This is not the region. Even down here, there are teeth on this side, but no teeth on this side. That is not the region. But I notice when I look at this that there are teeth here and teeth here, which means that this is the region that I will shade. And so that would be my final solution. Again, if I am going to graph and I have 2 lines, what I am looking for is the region of lines where there are teeth on both sides. Again, if this was a alligator's mouth, that would have teeth. That does not. No. This has none at all. No. This has teeth. That does not. No. And then this one does, and so that's how you would identify, or how I would identify it every time I graph. That's just a skill we have to work on, so we got to make sure we get something out of that. If I was asked to write a system of inequalities for this graph, the first thing I want to do is make sure that I understand some of the rules that I use to graph. First off, the y-intercept on this one is -1. Second off, I can find the slope by finding another good point, and it seems to me that this crosses at every nice spot, which means that the slope is 1. And so my first equation or inequality should be y, and then it should be 1x, and then because I went down 1, minus 1. The problem is I don't know whether it's less than or equal to, and so I have to kind of check 0, 0 out and recognize the way they shade this in the book. The yellow is for one of them, the blue is for the other one, and they use green because yellow and blue make green to represent the area that you have. And so since this is where we're shading, 0, 0 should be true. And so if I were to put 0 and compare it to 0 minus 1, 0 negative 1, again, if it should be true, 0 is actually bigger than negative 1, which means that the symbol should go this way. That's the first step. The second step is I notice that this line is solid all the way through, and so I have to put a line underneath it. Got to use a little bit of memory here and skill set, but again, if you've been keeping up with this, then that should not be as much of an issue. If not, you got some studying to do, and the good news is everything's on video in the past, so you can always find it. Other than that, the second line crosses right here at 1, 2, 3, 4, 5. So positive 5, and the slope on this seems to be right around here, which means I'm going down 1 and over 2, so it's negative 1 half x plus 5. And again, what I want to do is test 0, 0, and based off of this, 0, 0 should be true because I am on this side of the line. And so if I were to put 0 and then 0 plus 5 on the other side, in order to be true, the line would have to go that way, and so this would be it. I notice that this is a dotted line, which means that that should be my actual answer there. Alright. Outside of that, looking at question 3, which is a word problem, it says that I'm planning what to do after school. I can spend at most 6 hours daily playing basketball and doing homework. I want to spend less than 2 hours playing basketball. I must spend at least 1.5 hours on homework. What is a graph showing how I can spend my time? What I am going to do here is, because this is a graph, there are two variables here. X represents basketball, and Y is going to represent homework. So I'm going to label those on my graph here. Here's basketball, and here is homework, just so I understand whenever I label it what's going on. Some of these things, again, notice my numbers here. 6 hours doing basketball, less than 2 hours playing basketball, must spend at least 1.5 hours on homework. So if I was going to do this, because I have a fraction, I'm going to see if I can get up to 6. 1 half, 1, 1 half, 2, 1 half, 3, 4. Yep. So what I'll do is I'll count by 1 halves in this way, and I'll also count by halves going this way. And then you just have to go back and read the situation. It says I can spend at most 6 hours daily playing basketball and doing homework. What that means is, if I'm looking just at that statement, at most 6 hours daily doing either one, I know that I can either spend 6 hours playing basketball, maximum, I can't go past 6. I could also either just spend doing homework 6 hours. And so this line, from the point of me doing homework for 6 hours, which is one option, is homework for 6 hours, or basketball for 6 hours. This is going to give me all of the solutions that satisfy that situation. So this is my maximum line. So I can't do any more than 6 hours doing that, can't do any more than 6 hours that. This represents the max line. And again, if 0, 0 is true, because 0 hours would be good, I'm going to shade on this side of the line. It also says I want to spend less than 2 hours playing basketball. Less than 2 hours playing basketball. So 2 hours being my basketball here. If it's less than 2, that means it can't equal 2, so I'm going to put a dotted line or dashed line. Notice how I have to kind of make it go right here. And the numbers that are less than 2 would be 1 hour or no hours. So again, that would be on this side of the line. Then it says I must spend at least 1.5 hours on homework. At least means that 1.5 is good, and so 1.5 homework is here, And so I'm going to draw a straight line going across there. Again, at least 1.5 means that I have to go higher than 1.5, which means that I would shade this way. And so now what we are looking at is the shape where this is true, that is true, and this is true, which puts me way over here in this area here, which would represent the graph that we could have. So whenever that situation pops up, again, if you have a maximum amount of time, just simply put that max over here, put that max over there. That line represents your maximum. If they give me something like less than 2 hours playing basketball, go to basketball, make sure it's less than 2. Again, use the proper line. And then 1.5 hours on homework means go to homework, go to 1.5, and at least 1.5 means you have to shade up. And after that, you simply have to make sure you think your way through it and do what you need to do to knock that out. Okay? So as you close this up, we have 3 guided practice questions today. Again, make sure that you do your work on a separate sheet of paper. Keep in mind this is our second day and that this video was much shorter, which means you should be able to kind of finish it. And this is going to be the second part of your class activity. So the first question is just asking for the graph of the system. Again, I don't need it to be perfect, but I should at least be able to see the marks. If I am going up 7, I should see 7 marks, a dot, and whatever else is going on. Again, label that for me if you're counting by anything other than 1, but if you're just counting by ones, I don't need labels on this, not on this part. But again, the first thing we want is a graph of the system. Number 2, I want you to write a system of inequalities for this. The shaded portion, the true shaded portion, is down here, just so you know, because that is the green part, so you understand what's going on. This is the area that they're working with. And then the third question is similar to what we had here. You want to build a fence for a rectangular dog run. You want the run to be at least 10 feet wide. The run could be at most 50 feet long. You have 126 feet of fencing. What is the graph showing the possible dimensions on the dog run? So you're going to have to change your numbers a little bit on the parts there, but this graph should have a axis that kind of goes like this. Don't forget to label your axes kind of like I did in my problem. Make sure you're telling me what you're counting by, so that I can see what's going on. So again, you can work together on this. Just make sure you knock this out and get this handed in so I can at least evaluate how you are learning this information. Again, other than that, we have 2 days of review. If you have time or you have computer access, you might want to start looking back at your substitution elimination notes, though we will go over it briefly tomorrow and Wednesday. Or sorry, tomorrow and Wednesday. Thursday I think will be something different, but other than that, like I said, knock it out. Good luck.